number as your x values get bigger and bigger. So this actually means then that we can write a limit equation for the letter e. So now on your calculator, I want you to look for the letter e. It's going to be e to the power of x, or e to the little hat symbol. And I want you to type in e to the 1. No, that's not e prime. That is e to the exponent 1. So if you type that into your calculator, you will get that constant. So just like we have a constant for pi, because it's part of a ratio, it's the same thing with e. Here's the definition of what e is. All right, so if we have to say what the derivative of e to the x is, look how awesome this is. The derivative is e to the x. Okay, so if you're to look at inverses, going back to advanced functions if you have it, if not, if you have y equals 2 to the x, the inverse of that is log base 2 of x. So the base stays the same. And if you weren't sure, remember when you take inverse, you have x equals 2 to the y, and you want to solve for y. So if you solve for y, let's take the log of both sides. And then what happens if you have the log with something that has an exponent? Yeah, you move it down. So now you have log x equals y log 2. And then you can divide by log 2. And how else can we write this? Yeah. Okay, so that's how you find the inverse of them. So now if you look at what we're doing with e's, if you have e to the x, the inverse of that will be y equals log base e of x. However, if you have log base e of x, we don't write it like that anymore. We write it as the ln of x, which is a natural logarithm. If you want the key features, page 261 has all the key features for both of those graphs if you want to get those. So the last part I want you to notice is this right here. Yoink. So if we have ln of e to the x, what happens when you have two things with the same base? So this has the same base as this. What does it have to equal? It has to equal just the exponent. So the ln base, which is really a log base e, and it has an e put in, so it has the same base with the ln and the same base with the exponential. They're inverses of each other. So those cancel out, and you're left with just the x. Likewise, if you do that in the reverse order, we have a base of e, and we have ln, which also has a base of e. So all you're left with is x. So we're going to evaluate these different expressions. What do we get for the first one?
554.598.
Okay, and the next one?
0.7165.
What did you say? 7?
I got 7, 7.
Okay. What about ln of 10?
2.3.
Good. Ln of negative 6.
I'll wait for it.
So this is undefined.